In this video, let's take a look at the DS module. So this is a module that allows you to remove sibilants in a voice. And sibilants is those sort of sharp tones from the pronunciation of S sounds, SH sounds, and even C's, F's, and X's. Over here, I've recorded a voice where I've pushed the S sound just to accentuate it and see how it can work with this module. Take a listen to the audio sample over here. Here, we're going to be using the de-essing module and seeing how many of those S sounds we can remove from this audio track. So let's test out the de-esser. So you can definitely hear those pushed S sounds in that audio sample. So moving over onto the module, you've got two modes, classic and spectral. Starting off with classic, this is a full band attenuation of the sibilants. So it goes across the whole frequency band, so it'll attenuate anything at the threshold point and attenuate it. So you've got this threshold that acts like a compressor. So you'll set the threshold level, and when that audio passes that threshold level, it'll be pushed down, and you can see the reduction meter over here. Then you've got absolute mode that I will get to in a second. But first, let's take a look at how to use it without the absolute. Without the absolute, you're going to have a bit more of a natural sound when it attenuates the audio. So when you're not in absolute, you're in the relative mode, and the relative mode calculates the level of the vocal and compares it to the sibilants and then makes the adjustment. Then the cutoff limits the frequencies triggering the de-esser. So anything above this is where the sibilance is going to be detected. And normally the sibilance is going to sit in the higher frequency areas. And in the bottom over here, you can choose to output only the DS sounds. So let's turn this off, make a selection, and then preview it with the current settings. Here, we're going to be using the de-essing module and seeing how many of those S sounds we can remove. You can see that reduction that's happening over there. I'm going to pull up the cutoff frequency and pull down that threshold even more. I'm going to bypass it, preview it, watch over here. Here, we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Now before, here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. So you can definitely hear how it's pulling down those S sounds. And that's also determined by the speed. With the speed, you've got a fast or a slow. The fast is a fast attack and fast release, where the slow is a slow attack and slow release. If you hear too much transient reduction, it means you set it too fast. And if you've got too much high frequencies, then the compression is too slow. It works pretty well set to the fast speed, but let's try out the slow speed as well. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Now back to fast. Here we're going to be using the de-essing module and seeing how many of those S sounds. I like the fast speed and how it reduces those transients on those S sounds. Now, that is the more natural sounding algorithm of the classic mode. Now let's turn on absolute, which means it's going to attenuate all audio that happens at that threshold, not only the sibilants. Let's preview that. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. And now relative. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Definitely sounds way more natural in relative mode as opposed to absolute. Now let's take a look at spectral. Now with spectral, it's a multi-band attenuation of the sibilants, so it's honing in on only the sibilants and not the other frequency areas. And how it does this is it uses these two parameters here, which is the spectral shaping and then the spectral tilt. If you've got the spectral shaping all the way at 0%, it retains the natural tone of the sibilants. But if you increase this all the way to 100%, it's going to conform it to the spectral tilt, where you can determine what type of noise you want to use on that sibilant. So just mentioning again that the spectral mode helps reduce the sibilants and not the surrounding frequencies. So let's take a listen to this. We're going to set the spectral shaping all the way to 100% and then hear how you can choose between white, pink, and brown noise to shape that sibilance. Now let's preview it to see what it sounds like. Let's pull the threshold down quite a bit and preview it. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. So you can hear how the spectral tilt sound is shaping those transients when they push over the threshold. So really, the spectral mode allows you to hone in on the sibilance and shape the characteristics of that sibilance as you reduce it, and where you can use the spectral tilt to shape the sibilance with a type of noise. And what I didn't show is this output S only mode. So I'm going to take that and preview it so you can hone in and hear just those S's that we want to pull out. Change the noise to white. We can remove. Here we're going to be using the de-essing module and see how many of those S. And then down to brown. We can remove. We can remove. I quite like it on the brown tilt, and I'm going to pull this threshold up slightly because it's pulling out a bit too much of the sound. So let's do one more preview. Here we're going to be using the de-essing module and seeing how many of those S sounds we can remove. So let's compare it now. So I'm going to have these settings, click compare, add it to the compare settings. Then I'm going to switch to pink noise, compare that as well, and then to white noise and compare. And just to demonstrate it as well, let's switch to classic mode and compare that as well. So here we've got 4 different options. Let's play the original audio. Here we're going to be using the de-essing module and seeing how many of those S sounds. Here we're going to be using the de-essing. So let's compare the original audio. Here we're going to be using the de-essing module and seeing how many of those S sounds. Here we're going to be using the de-essing module and seeing how many of those S sounds. Here we're going to be using the de-essing module and seeing how many of those S sounds. Here we're going to be using the de-essing module and seeing how many of those S sounds. Here we're going to be using the de-essing module and seeing how many of those S sounds. Back to the original. Here we're going to be using the de-essing module and seeing how many of those S sounds. I quite like this brown setting with the brown noise and spectral tilt. Here we're going to be using the de-essing module and seeing how many of those S sounds. Obviously the classic mode pushes it quite a bit. Here we're going to be using the de-essing module and seeing how many of those S sounds. So make sure you don't lose too much of the transient when you pull down the threshold to reduce that sibilance. If you find that you are, just pull this threshold back up to retain the quality of the audio. So that's the de-ess module. Now let's move over to the next module.